this section has to do with the fundamental theorem of algebra, and with a name like that, you know it has to be a pretty big deal. So the theorem itself is actually a fairly simple theorem as far as mathematical theorems go, but the gist of it is that whatever the degree of your polynomial is, that is the number of solutions you should get. So that's written right here. Degree of polynomial equals the number of solutions. The degree of a polynomial is the biggest exponent that it has. Whichever x has the biggest exponent, that's how many solutions you should be able to get. And so there's lots of ways to go about this, but assuming that we want to do this algebraically, in other words, without just using our calculator, we are going to do things like factor and use division, either long division, or we'll mostly use synthetic division to be able to completely factor out what we have. And we may have to end up using things like the quadratic formula, but the idea is that we'd start off knowing how many answers we should get, and we can use that to help us know when we're done and help us, and like on a bunch of these, they're going to give us part of the information and we're going to use that. So these first two examples, the instructions say that given one of the factors, find the remaining factors and then write your answer in factored form. So if I look at this, it's x to the fourth power, which means if I wanted to go all the way and solve this, I would get 4 answers. So we don't actually have to go all the way and get those answers because we're just trying to basically write this out as a bunch of different parentheses. They're telling us that x plus 2 is a factor, which means if I divide what I started with, x to the fourth minus x cubed minus 7x squared plus 6 by x plus 2, what I get will mean like I'll have x plus 2 and then that answer, like those two things multiplied together, should give me what I started with. And so then we'll take what's in this parentheses and we'll try to split it up more, either by factoring or something else. But our very first step we want to do is synthetic division, because as long as there's not a number in front of x, we can use synthetic division instead of using long division. Remember that to use synthetic division, if they give you x plus 2, you have to set it equal to 0 and solve, and that's the number that goes over here. So this is -2. We're going to use just the coefficients in front of our x's, so 1, -1, -7, 1, and 6. You got to make sure that they don't skip over anything. Like if they had skipped over x cubed or something, we would have to put a 0 in that spot to make synthetic division work right. So synthetic division is where we drop the first number, we multiply, add, multiply, add, multiply, add, multiply, add. And if you're unfamiliar with synthetic division, then you can find other videos, like I have a video on my channel of just synthetic division, or you can Google it or whatever to find other videos on just that. But if we start off with x to the fourth, then our answer starts with x cubed and then x squared, then x, then a number, then a remainder. So I'm going to rewrite this up higher so that I can save some room. So we divided x plus 2, and now we're getting an answer of x cubed minus 3x squared minus x plus 3. Now our remainder is 0, so we don't need to write it. So the idea is that we've split up x to the fourth, blah, 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 into these two parentheses, but we want to keep going and split up as much as possible. So hopefully we'll be able to split it up until everything is just x plus something or x minus something. So I need to look at the second parentheses. When I have 4 terms, if I'm trying to factor, I have to be able to factor by grouping, or there's not really any other way of doing it. So factoring by grouping is where you look at the first 2 things and you say, what do those have in common that I can take out? They both have an x squared. So we're going to take out x squared, and that leaves us with x minus 3. Because x squared out of x cubed gives us x. X squared out of -3x squared gives us -3. Then I look at the last 2 and I say, okay, what do they have in common? these don't actually have anything in common, but we want to take out something so that our parentheses will match. And so if I just put +1 here, my signs are wrong. So I'm going to put -1 and then change this from a -x to a positive x, change this from a +3 to a -3. Because in order for this next step to work, these two parentheses have to be the same. Because what we do is we write down that parentheses, and then we write down what's in front of our parentheses in another set of parentheses. So this is x² - 1. And then I'm going to drop this parentheses down that I started with. So we just made some progress, because now we know that x⁴ minus x³, blah, blah, blah. Our original problem that we started off with factors into x + 2 times x - 3 times x² - 1. But when we're doing this, like, we want to check and see, is x² - 1 something that I can factor? Now, if this had been a +1, then we couldn't. If it's x² plus something, you can't factor that further if there's just two terms. But since it's a minus sign, and since I can square root 1 and get 1, this does split up into x + 1 and x - 1. Because that's like a special factoring thing. With two terms, the only way you can factor it is if it's a minus and something that you can square root. Otherwise, we would just leave it alone. So this did split up into 4 different parentheses. If we wanted to find the answers now, if we wanted to set this equal to 0 and finish solving, it would be really easy, because it would be -2, +3, -1, and +1, because you set each part equal to 0. But it didn't ask us to. It asked us to write it in factored form. So this is the kind of answer that we would be looking for whenever it wants factored form like that. So let's try that on this next one. So we know that this is a factor, this x - 1, and so we can do synthetic division. But we also could factor this, what we started with, by grouping if we wanted to, because these two group together, you can take out an x³, these two group together, you can take out a -8, and that will actually let you keep going. But since they gave us x - 1, let's go ahead and do it that way. Let's divide by 1. Now, there is no x² here, and so we're going to have to put 1, -1, 0, -8, and 8. And if you try to do it without that 0 there, you won't have enough numbers. Like, you'll run out of numbers before you get to where your remainder should be. And then most of the time, students just like don't realize that that means they messed up, and they just try to go along with that, and that's not how that works. Like, you need that 0 there. So drop the first number, multiply, add, multiply, add, multiply. Man, that's a lot of zeros. 1 times -8 is -8, 0. Now on these, if it is a factor like they told us, we need to get 0 for our remainder. So that's not just like a coincidence that we got 0 for our remainders. It has to equal 0 at the end, or it wouldn't be a factor. So since I started with x⁴, this is x³ plus 0x² plus 0x minus 8. And so what we know is that what we started with is x - 1 times x³ minus 8. What we want to do is try to factor x³ minus 8 farther. There's a couple different ways we can do that. There's actually a set of formulas for when you have something cubed minus something else cubed, or something cubed plus something else cubed. And there's a way to factor those specifically that they're not too difficult as far as memorizing things go, but you do have to actually like try to memorize them if you're planning to do it this way. So the idea is that I have to be able to look at x³ minus 8 and say, well, I know what the cube root of x³ is, and I know what the cube root of 8 is. Both of those have a cube root, so x and 2. And that's what tells us what a and b in this formula are. So in our case, we've got x³ minus 8, and 8 is really 2 cubed. And so a is x, and b is 2, so we could write this as x minus 2, and then fill in a and b in the second set of parentheses. So a² becomes x². a times b, a is x and b is 2, so that makes 2x. And then b squared is the last thing squared, so that's plus 4. And this is actually pretty simple. Like, you just cube root both of them and get x and 2. The first thing in this parentheses is x squared. The last thing is 2 squared. And in the middle is the two things multiplied together, x and 2. The only part that's kind of weird is keeping track of where your negatives and positives are. So on this formula where it's minus over here, it's minus plus plus. If we add x cubed plus 8, that'd be plus minus plus. All that is to say that in order to actually factor x cubed minus 8, we use that formula and we get x minus 2 times x squared plus 2x plus 4. And then we would check and see if this factors x squared plus 2x plus 4 by saying, is there anything that multiplies to get 4 that adds to get 2? And there is not, and so this is our answer. This is a case where the fundamental theorem of algebra says that we should get 4 answers if we solve this all the way to x, but because of this not factoring at the end, we only get 3 parentheses. But since x times x squared is x to the 4th, then we have all the parentheses we need. The other way of going about this, if you're not a fan of this whole formula thing or it didn't make sense, is you can graph x cubed minus 8, and you can look for where x cubed minus 8 goes through the x-axis, and it should go through at 2. And so what you can do is you can divide 2 into what we have right here, 1, 0, 0, negative 8. And this answer will give us this second parentheses right here. So 1, 2, 4. See, it gives us x squared plus 2x plus 4. And so what we're doing when we divide 2 in is we're saying that x minus 2 was a factor with x squared plus 2x plus 4. So that's how we would go about something like that. Another way they can give us problems is they can give us a 0. So there's a bunch of words that mean the same thing. Zeros, roots, solutions, x-intercepts. All of these have to do with the places where if I set an equation equal to 0 and I solve for x, I get what this is talking about. We call them zeros because you're setting it equal to 0, or roots because like of the idea of like having square roots. Like when you solve x squared equals something, you get roots. Solutions because there are answers. They're x-intercepts because this is literally where the graph crosses the x-axis. So they are, in this case, either giving us an answer, or on this next one we'll have to use our calculator to find one. They want us to find all the other ones. Thanks to the fundamental theorem of algebra, we know how many we should get. This is on the first example. There's 4. Hang on, I gotta sneeze. JK, I don't have to sneeze. Okay, so this is x to the 4th, so there should be 4 answers, and they told us one. So what we can do is we can use synthetic division. They're telling us that x equals 5, so we don't change the sign of this because we know that this really is 5. On the other ones where they were factors, we set it equal to 0 and solved for x. Here we already know what x is, so we don't have to change the sign. So we put the numbers 2, negative 8, negative 9, negative 4, negative 5. And drop the first number, multiply, add, multiply, add, multiply, add, multiply, add. Then we're going to write our answer and then see if we can factor to find the rest of the zeros. So this is start off as x to the 4th, so this will be x cubed. 2x cubed plus 2x squared plus x plus 1. So if there are 4 terms, it's factor by grouping or bust. Like, you either can factor by grouping or you can't factor it. So I'm going to look at the first and say, well, they have a 2x squared in common. And if I take out the 2x squared, I get x plus 1. the last two don't have anything in common, and it's already actually what we want. So we're going to put plus 1 and pretend like we're taking out a 1, which leaves us with x plus 1 here. But you can't just put nothing there, because we want to say, okay, they have an x plus 1 in common, and then 2x squared plus 1 goes in our other parentheses. And if you didn't put this plus 1 here, you might not know what to put in this spot. There has to be a 1 there, because if I FOIL this out, I need to be able to get back to what we started with. And if you don't put plus 1, you won't be able to do that. So we're trying to set this equal to 0 to solve, and that means that I can set each of these parentheses equal to 0, x plus 1, and then 2x squared plus 1, and then try to solve these. Well, x plus 1 equals 0 is easy, because you just subtract the 1 over and get x equals negative 1. 2x squared plus 1 equals 0 is a little bit trickier. You have to subtract 1. And then divide by 2. And you get x squared equals negative 1/2. When I square root both sides, I get x equals. We have to remember that when we're solving an equation and we square root at some point, that there has to be a plus and minus sign, because x squareds give two answers. That's the fundamental theorem of algebra. And so if you don't put plus and minus, you didn't get two answers. Now when I go to simplify this, the square root of a negative number gives me an I. I can square root the 1 on top and get 1, but I can't square root the 2 on bottom, so I have to leave it as square root of 2. And then if we want to rationalize this so the square root's not on the bottom, we'd multiply the top and the bottom by square root of 2. So this gives me plus and minus I square roots of 2 over 2. That's two answers, because there's a positive I square root of 2 over 2 and a negative I square root of 2 over 2. And then x equals negative 1 was an answer. And then for our fourth answer, we have to remember what they told us to start off with, which was that x equals 5. On this next one, they didn't tell us an answer to start off with, and so we actually are going to need to graph this on our calculator. And so if you go to your calculator, and if you're using a TI calculator, you'd go to y equals and just type this into one of your y equals spots. And then you want to go to graph and look at the graph. What I've done is I've graphed this on a website. It also has an app for your phone that's called Desmos, Desmos, and so it's a really cool calculator that is online that will show you things where you just have to click on these points and it'll show them to you. What we're looking for when we look at our graph is places where it goes through the x-axis that are nice whole numbers. And so there's 3 places where it goes through, but the only one that I'm really going to care about is this one where it goes through -2. And even if you're on a TI calculator, it should show you -2. It should go through that tick mark if you have a standard window going. So what I'm taking from this is that x equals -2 on this problem. That is one of my answers. And so then I'm going to use that with synthetic division. If you looked at this to start off with and you're like, couldn't we just factor by grouping? We almost can, but it doesn't actually work out. When I take the 2 out of these that it has in common, my parentheses don't match up. So that's why I'm not just factoring. So I'm going to put -2 over here with 1, 4, 2, and -4. And do synthetic division. And then write my answer. I started with x cubed, so this will be 1 power less, which is x squared plus 2x minus 2. And since it's x squared, at this point I can go ahead and set it equal to 0 and see if I can figure out what my answer should be. So to do that, I can try factoring. I can say what multiplies to get -2 that adds to get +2, and nothing works. And so if we try to factor and that doesn't work, you're pretty much stuck doing the quadratic formula, which, just as a reminder, is x equals -b plus and minus square root of b squared minus 4ac all over 2a. And so in this problem, a is 1, b is 2, and c is -2. So we'd say x equals -2 plus and minus square root of b squared minus 4ac all over 2a. So we do what's underneath the square root first, and we say, okay, that's 4 plus 8, which is 12. And on bottom, we go ahead and do 2 times 1. We simplify the square root of 12, and we say, okay, that splits up into 4 and 3, and I can take the square root of 4, I can't take the square root of 3, so that becomes -2 plus and minus 2, because I square root 4, times the square root of 3, over 2. And it's at this point where I have a number here, here, and here that are all can be divided by the same thing, that now I can simplify this all by 2. So if I do -2 divided by 2, I get -1. 2 divided by 2 is a 1 again in front of our square root of 3 with a 1 on bottom, and I don't really need the 1 on bottom. So -1 plus the square root of 3 and -1 minus the square root of 3 are 2 answers. And then x equals -2 is an answer. And so if you looked at the graph, this right here is giving us those 2 decimal answers. And the thing is, we wanted to get a more precise answer, which is -1 plus the square root of 3, which we haven't rounded or anything like we would have had to if we wrote down just the decimal from our calculator. The other thing that goes along with this is, what if we have answers and we want to write the actual polynomial that goes with it? And the key thing here that makes a difference is that if we have an irrational or imaginary root, so if we have either a square root or an I, its conjugate, or in other words, its opposite, also exists. And so what that means is, they tell us the square root of 5 is an answer. We can say, oh, well, negative square root of 5 also has to be an answer. That's because whenever I go to multiply this out by making these factors, if I don't have x minus square root of 5 times x plus the square root of 5, I won't be able to cancel out my square root. So I'll end up with a polynomial that has these yucky square roots in it. So, and then I also need x minus 2. The 0, you can put x minus 0, or you can just put x. But the idea is, if these are answers, then the step before this, they would have been factors. And so the step before that, like, we need to multiply this out to figure out what it would be. I'm going to multiply these 2 things together and these 2 things together, and then take those answers and multiply again. So on this second part, x times x gives us x squared. And then x times the square root of 5, and then x times negative square root of 5, those become opposites of each other. I'll go ahead and write it down just so you can see. We get this, and those are opposites of each other. So even though they're x's instead of numbers, those cancel. And then negative square root of 5 times positive square root of 5 is negative square root of 25, which is just -5. So this is x squared minus 5. So you can see how great it is that we did that, because the square roots canceled. If I distribute this x into this parentheses, that gives me x squared minus 2x. And now I'm going to multiply those 2 together here at the end. X squared times x squared is x to the 4th. X squared times -5 is -5x squared. But I am going to write this in standard form. So I'm going to write that with a gap, because -2x times x squared is -2x cubed. Standard form is where they go down in exponents. So -2x times -5 is positive 10x, and that'll go at the end. So this is our polynomial that, if I set it equal to 0 and solve, gives me these answers up here. On this next one, same kind of deal. If I know 4i is an answer, then -4i has to be an answer. And so I'm going to set this up as factors. And then multiply it out. So you can multiply it in any order you want to, but it will always be easiest to do the 2 that go together, because it's going to cancel things out. It cancels things out because they're the same parentheses with one as a minus and one as a plus. So every time you do this, the outer and inner terms should cancel, which means you can skip the outer and inner terms. So my first term is x squared. Last is negative 4i times positive 4i, which is 16i squared. Well, 16i squared, the I squared is going to change this to a plus because I squared is negative 1. So this is x squared plus 16. And that's what I'm going to multiply x minus 3 by. So again, we're going to FOIL this out. That's x cubed and then minus 3x squared plus 16x. And then negative 3 times 16 is negative 48. And that is all of this section that's about the fundamental theorem of algebra. The idea is that if we know what some of the zeros or factors are, we can use synthetic division so that we can get something simpler, so that we can use other things like factoring or the quadratic formula to solve for the rest of our answers. So there you go.